For the first talk, we will all virtually travel to Germany to learn how to build a weather alarm app with Strapi. Please welcome our first speaker, Heiko Voigt, lead architect at SIT GmbH.
Thank you, Anastasia, for this kind introduction, and welcome to my talk about using Strapi, NodeRed, and Ionic to build a weather alarm application. I should have come up with a shorter title, but you can read the rest of it right here. But anyways, so a couple of things about me. My name is Heiko Voigt. I'm a lead software architect at SIT GmbH in Germany. I'm working as a full-stack JavaScript developer, and one of the projects that I've been doing for the last couple of months I want to talk about today. To quickly go through the agenda, we will just take a look at what the customer is and what they're doing. Then we're going to take a look at the business problem that we were facing when we started the project. And when that is done, we'll just take a quick dive into the solution architecture about what we have built. And we're going to take a look at the front end. And then it's demo time. And we're going to take you through all the components that we have built through this demo. And when we're done with the demo, we'll just wrap it up and just take a quick peek on why we think Strapi was a great choice to solve this problem. So about the customer. The customer of mine is a subsidiary of the Ministry of Agriculture in Rhineland-Palatinate. And this subsidiary specifically caters about communication and knowledge sharing between all the market participants in the agricultural sectors. This is, for example, of course, for all the farmers that are out there, but also like meat producers and, of course, the governmental agencies on the European level and the national level in Germany, but also on the provincial level. And also people like agricultural consultants that can work with different farmers on different topics. And based on their technological platform, on their technology platform, they can share knowledge with each other, and they have a communication platform to interact with each other. Additionally, the customer provides base data to work with in the agricultural sector, like weather data, weather outlook, real-time weather prognosis, and all those kind of things, and other topographic information, for example, for crop producers and other things. For our project, there was one relevant component that we have had to work with, and this is the so-called Geobox Messenger. This messenger component is a information system that acts as something like a message-based interface like Slack between all of the market participants that I was referring to, like the farmers, the consultants, the pharmaceutical industry, and they can be used, or they are using this information system to exchange data, to subscribe to information channels that are available on this tool, but also to do direct messaging between each other and to have this work on a mobile environment. Now let's take a quick look at the business problem that the customer is facing. Due to the changes that we have seen in the agricultural sector over the last, I would say, decades, where we have moved from small units to bigger and bigger and bigger units with less market participants, there is a huge demand today for location-based, personalized weather and environmental data for your specific situation as a crop producer, for example, or wine producer, fruit producer, whatever you do, to be able to have a kind of a sustainable way of producing your crop, for example. Sustainable means how much pesticide do I have to bring out, and when is the best time to do this? When do I start watering plants? When do I have to cover them? All of these things and that have to be taken into consideration, to have to be done at the right time, at the right moment, and with the right amount of time to prepare for it. And this more or less granulates down to a demand for everything that's location-based. So based down to the specific field where, for example, your plants are growing, or your specific vineyard that might be another 2 or 3 kilometers away from other vineyards that you have. that have a different microclimate, and you have to adapt differently to different situations weather-wise. So this has to be huge demand, as I said, for that, for personalized data, location-based. Everything has to be provided centrally, because it's no longer possible for each and every producer to maintain all of like the weather information, weather data of his environmental requirements by himself. So this has to be done as a central service, but it has to be personalized for each and every market participant here, and it has to come out on a mobile device, because, well, most of the time, if you're a farmer, you're out on a tractor, you're out within the crop, within your vineyard, and that's where you want to have the information, and that's where you need it, and that's where you have to be able to communicate. Our specific business problem was to give the farmers, especially, the opportunity to book services from this governmental agency based on a location. So this means, for example, if you see right here, you have a farmer with a tablet, and for this specific location he's currently in, he's seeking for weather information and weather warning information in our specific case. So basically he selects his current location from a map, and then the system that we should build returns the available services, weather warning services at this specific location. And then the farmer can book these. For example, say if a drought is coming, I would need to know at least a couple of days ahead so I can start planning watering my plants. Or if it's like in spring or fall time frame, when do I get when do temperatures and humidity drop under a certain level where I have to cover plants and all those kind of things, right? So very simple examples, but these services should be bookable through a mobile device, through Geobox Messenger for the specific farmer in a specific location. That was the use case. And to broaden this up a little bit, we decided to not only build one or two hard-coded services, but to build a extensible service platform that has a quick ROI for the customer, so we can deploy it quickly. It's cost-effective, and we have a quick time to market with it to bring out these service booking opportunities to the farmers. And also one big consideration for the customer was we had to build it based on open source solutions. And that's exactly what we did. So let's take a quick look at the solution architecture. Well, as I already said, that we already had a base component that we had to use, and we're happy to use it because it's good. This is Geobox Messenger. This is, as I said, a messenger application. So you can have group chats or direct chats, similar to any other platform like MetaMost or Slack. The app itself communicates with any backend services through a centralized data broker, which is called GIM, and this is part of the framework that the application is using. The data broker more or less takes care of moving data in and out of the application instances on the mobile devices. So each mobile device connects only and solely to the data broker, not directly to any endpoint services. And currently, this Messenger app is heavily used already. You can just download it from the App Store, and it has and it comes with a plugin architecture, so you can build plugins based on JavaScript components and extend this application. That's exactly what we did. So we had a centralized data broker that our services could connect to, and then we have an extendable Messenger app that we're building on top of. So the next component that we had to build was the service management component, right? So we want to define services that can be booked from the Messenger app, and for that we need a place where we store our base data. We need to store things, for example, like definitions for weather stations that we want to talk to. We want to define the services itself. So what is a service and how is it defined, and what defines the service, and how does this all work together? And of course, then at some given point in time, we will receive bookings for this service. So somebody out on the application that, yes, I want to use this service, and I'll book it. So we have to store that somewhere, and all of that is stored in Strapi. That's what we decided to build in Strapi. The next big component that we had to build was a service runtime. So now that we have defined our services and the users can book the services, we then have to define where do we actually get the data from, and what do the services provide, right? And to do this, we also had to come up with a very flexible and open system, and that's why we decided to build this service runtime on top of NodeRed and have NodeRed talk to Strapi and implement the process flow. So for each and every service that we have one or more service flows in NodeRed defined. The NodeRed itself also keeps track of all the hard data that we need to provide to work with these services, like weather data, for example, to our extent. And it's also doing it connects the management component with the live data that is feeding in, for example, from the weather stations, and then triggers actions inside of the process flows itself. For those of you who don't know what NodeRed is a programming tool. It's a low-code, from my perspective, it's a low-code tool. A lot of you might know it from home automation, because it can talk to literally anything that's accessible through the internet. It brings a flow-based kind of programming model. So you have nodes and flows and data flows. And these process flows are defined by moving data from one node to the other. And each node does something specifically with the data, changes data, and moves it on to the next one. And so with this, you can build very complex application flows that, for example, take data from a web service, work with it, enrich it by calling other web services, pass it on to a database, and then the database does something like with it, computes something, whatever. And that's the basic idea here. It's built on Node.js. And of course, it has a huge amount of extensibility points. So the nodes that you can use are technical nodes inside of NodeRed, but a lot of them are talking to external systems, like services-based architectures, but also to hardware and IoT devices, whatever basically is accessible through the internet. NodeRed runs on literally anything that is capable of running Node.js. So even from a Raspberry up to I think I already have a COS on the mainframe implementation already, whatever that's good for. But anyways, okay. So now let's take a look at what are the artifacts that we have built, right? So on the left-hand side of this chart, you'll see the components that are responsible for handling the booking data from the mobile application. On the right-hand side, you see the components that we've built to manage our services. So if you want to book services, we have to define our services first. And services are defined by a group of parameters that the user can change. For example, as I said, if you want to get a frost warning in place, then we definitely have to define, okay, at what height from ground, for example, do we want to measure? What kind of humidity level do we want to measure? And several other parameters that define such a service. These parameters then have to be moved over to the mobile application to be picked up there, built into the front end. And so the user can define, for example, okay, if it's -2 degrees on 2 meters height, I want to get a warning for my apple trees, because then I might have a problem with the blossoming of my apples, right? So to do that and to come up, for example, with a service, we have to define where this service request is coming from. So what geo coordinates do you want this service to work on? And to do this, we will have to find a way of defining the location that the the farmer selects by reverse coding services, and to map the available services for the specific location for them, so he can pick the services that are available at his specific location, because not every service is available at every location. There are different provinces in Germany, and not every service is available in every province. So we have to do a reverse lookup to check, okay, what services are available at the given coordinates. And then we have to define a couple of other parameters, like the associated weather station, the closest one that we have to monitor for the specific booking. And also we need a reference on where to send any warnings to, which is done by a reference parameter, which is an internal customer ID. So we don't store any personalized data from the farmers or anything besides the geolocation that the service is booked for, and a reference to the customer to send back a message later on in the flow. So let's take a look at a couple of things, like what are the use cases for NodeRed and Strapi. And I mentioned that we are talking about weather data. Weather data gets delivered from hard installed weather stations that are located across the country, and they belong to different weather data networks, and they deliver data into a data repository at the ministry. So we have to define these weather stations that we can actually work on for our services, and that's this basic data comes from a data warehouse component at the customer, and we use NodeRed as well to import these into Strapi, so we can have them as a base data component in Strapi as well, and also we can maintain changes with that. So if a weather station gets decommissioned and a new one gets commissioned, we'll get these changes back and forth. The second use case is the more important one. This is, for example, the way that we build the communication between the data broker that talks to the mobile application, Strapi, and NodeRed in case of one of the services that are the service flows that are working on. So NodeRed, for example, is in our case is waiting for event resources, or an event source. In our case, this could be, for example, a table change in the data warehouse to initiate to say, okay, well, there's a weather station that has sent in a new set of records. If this happens, then we'll kick off a process flow that will look up for respective bookings for this process in Strapi, generate the data, and send it out through the data broker. So this is exactly what is done here. And also NodeRed is keeping track of the data sources itself. So for example, if we talk to a winery, we have different services that we talk to. Then if we talk to, for example, the fruit producer, like someone who's growing apples or other fruit. So there are different data sources and different event sources in NodeRed that then trigger a process flow that gets its base data and its data to work on from Strapi, and then sends out the messages through the data broker. So how does it look like from in such a sample flow? This is for example, what I quickly described here. We get a new event from a weather station. The weather station sends some new data. We then kick off a flow automatically in NodeRed to read the respective bookings for this specific process or for this specific service for a specific weather station from Strapi. We get the data from the weather station. We'll check parameters. As I said, we could, for example, if we say you want to monitor frost in 2 meters height, that's a parameter that the weather station delivers. So we can check, does this match? If so, we'll generate a message. The message gets sent out to the consumer via Firebase. We'll log that stuff and finish, and we wait for the next message or the next event to occur. Quick look at the front end. The front end is, as I said, is part of the GeoBox Messenger. It's talking to the data broker backend, and we'll definitely come up with a list of services that you have currently booked, and of course you can add a new service to book. This calls a booking wizard, where you just select a geolocation. You then get presented with a list of available services at this location. Then you can define your service by fine-tuning the parameters that you want to monitor. And then you can save that. And this is all done through REST APIs and REST calls that are related through the mobile application, through the data broker to Strapi, right? This is all going back and forth to Strapi. Besides the services that we had for geolocation with Nominatum, that's also called through a REST facade here. And now it's demo time. So let's have a quick look at the Strapi structure. So what have we built on Strapi? And then we're going to take a look at the front-end test application. This is a React application that we use for internal testing. And I'll show you a couple of the NodeRed flows, and then we'll take a look at the Mattermost, the message integration. For the sake of the demo, I hooked up NodeRed to our internal Mattermost chat facility, so we'll see a real-time warning popping up in the Mattermost chat. So that's what we're going to go through, and now we'll switch on over to my browser. And this is of course Strapi as you know it, and these are our collection types that we see right here. So for example, we have the services, and in our system here we have two services booked: Spätfrost Alarm and Pflanzkübel Alarm. Spätfrost Alarm is the use case that I talked about, where you measure a couple of parameters for frost warnings during the night, and that's one that we're going to book later. We have other base data that we need, like provinces over here. Then we have a couple of our parameters that we define. These are all parameters that are related to a specific service, and Strapi takes care of that. I'm going to go through that quickly because I want to show you the bookings here. So these are the bookings that we currently have, and if we sort them, we're going to see that there are 36. The last ID is 36, so keep that in mind because we'll have to look that up later. So Strapi keeps track of all the base data that is coming from the booking system, and also takes care of a lot of the base data that we need to make these services work. Now, if you want to book a service, I said this is our test front end that we came up with. And it's basically doing the same thing that you would do on the mobile app. So you can, for example, select a geolocation. I'm going to do that quickly. It's browse through my map. And I'm going to go, let's go right here. This point here. I can then check my location. So this is the service to the geo reverse lookup. And this gives me my available services at this specific location coming from Strapi. So this was a call for the geo reverse lookup service, and then we asked Strapi for the services that are available. And I want to use the Spätfrost Alarm as I described. Then I can select a couple of parameters, like I said, temperature in 2 meters height. If that goes below 0, I want to have a warning, and I want to have the dew point in 2 meters height also defined as a parameter, and this is for whatever value you're going to set here. And then we can send this booking, and this is the same stuff that happens through the mobile interface, and the abo got created. So if you quickly check back in Strapi, we should now, if you check our abos, we should have a new one, and there it is, number 37, and these are our this is our selected location. This is our customer token that we received that we'll need to send messages to later. What we also did here, when the booking gets stored, we're going to select the closest weather station automatically from the list of weather stations, and these are our parameters that we define. Now we have our services defined, we have our services booked. Now let's look at the service implementation. This is NodeRed over here. And what you see right here is a typical flow in NodeRed. And this is, for example, the flow that I want to show you today for one of the services that we have. And what you see right here in my sample flow, I'm scanning a directory, right? So I'm waiting for changes on a directory. This could be literally any endpoint. This could be a service endpoint. This could be a socket.io call. This could be a REST service call, because NodeRed can also act as a REST service provider. This can be done on a scheduled basis or whatever you want, right? And then we're going to check for a specific file, which are these two files that we're going to work with, and then we process the flow. So we read the data that's coming from the weather station, we parse the data, do a couple of things with it, And all at the end, we format a output message in JavaScript. And this is literally everything that you need to do from a coding perspective in JavaScript. Everything else is just by pointing and clicking and building the respective relations between the nodes. And then you will send this message off to Mattermost, to a specific chat. So how is this working? Let's take a quick look. I have a file that this is, for example, this is one of the simulated things that we have from the weather stations that sends in the data. And if I change this, you should take a look at the left-hand side, the right-hand side here, where all of these actions are taking place, because this is when something happens inside of NodeRed. Now we're going to write this out. Let's cancel this, do it again, change something, write the file again. And with this write of the file, you see there's been a change in here. And when we switch over to our Mattermost channel, and I'll have to move the window in here so we can see that, just a second. And we just see, this is our action message that we just received. It reports, there's a frost report for tonight. So this is how we integrate those components. And I have a couple of different flows in here that are working differently depending on the services. And more or less for each and every service, there's a different flow that takes part here and does the respective things with sort of integration from Strapi. Okay, so that was the demo. And now, as I said, that's just a quick summary of why Strapi and NodeRed. Well, we had the goal to build a loosely coupled system, which allows us to extend on literally every angle, right? From beginning at the Messenger app, going through the service management component that allows us to extend literally everything that we want to change in the services and extend the services to any given need. And also from a service runtime perspective, to be able to talk to whatever we want to talk to, whatever comes to the mind of our customers, they were able to do this with NodeRed and Strapi, right? So they can just simply build those components. And also what's important, all of the interfaces that you've seen are maintained and run by citizen developers. And the 2 citizen developers that are currently running this system, which currently has 9 services deployed, is done by 2. Is run by 2 people, and these guys are actual farmers. They're no IT professionals, they're farmers, right? And that was the goal for this. So for us, Strapi and NodeRed have been a perfect match to bring those components together. We can implement and deploy new services literally within hours. It's really extremely fast and quick. We can build the services independently from their actual implementation in code or in data. And we can build services that combine the existing data plus new data and new service providers and everything into one place. And without changing the services, we can change the data and process implementation that is taking place in the backend, right? So these are completely separated out. And as a true low-code environment, all of this can be maintained. And this was an important part by citizen developers inside of the customer's organization. So they don't need any IT experts on that. They can basically do it themselves. So that was pretty important for them. That concludes it for today. Thank you very much. I'm available for questions in the chat. And thank you.
Wow, thank you for this presentation, Heiko. It's amazing to know that Strapi helps to develop German agriculture. I hope you have a good harvest this year.